Okay, good morning everybody. So today we're going to have a look at some videos where we're calculating velocities and acceleration for a particle moving in a three-dimensional space. We'll use these examples to look at things like speed, as well as whether the objects are perpendicular, etc. So our first question is, we have an object which has a position vector r of t equal to t minus cos t I plus sin t j, where t is greater than 0 and less than 2 pi. The first thing we need to do is find an expression for the velocity and the acceleration, and then we need to find out what time the speed is a minimum and what the acceleration at this minimum speed is, and when the acceleration is perpendicular to the path of the object. So let's start off by finding our velocity and our acceleration, or finding expressions for the velocity and acceleration. So the first thing I know to find the velocity is I need to differentiate the position vector. So if I differentiate the x component first, so I'm going to differentiate the x component first, that would give me 1 plus sin t. The derivative of negative cos is positive sine. And then that will be my I component, and the derivative of sine t is cos t, and that'll be my j component. So this is my velocity, and when we differentiate, I can only take that from the domain of the original function, and I exclude the endpoints when I differentiate, so I don't actually include the 0 and the 2 pi. So now we want to find out the acceleration, and the acceleration is when I differentiate the velocity. So when I differentiate when I differentiate 1, I get 0, and then differentiate the sine component and we get cos of t, and then differentiate cos and we get negative sine. So I don't need a plus there, I need a negative sine tj. And again, this will be between those two values without actually including the endpoints. Alright, so we have our expression for velocity, we have our expression for acceleration, and if it helps, then sometimes it's just useful to write your little v and your little a in there instead of those dots to help you understand what's going on. Both are perfectly acceptable in an exam situation. If the exam was using the dots, then I would use the dots as well, just for consistency. Alright, so that's part A done. For part B, what I need to do is find the time the speed is a minimum. So let's think about what is the speed. Now we know the speed is the magnitude of velocity. So speed equals the magnitude of velocity. And how do we write that in mathematical symbols? We can have the magnitude of velocity. Okay, so if I want to find the magnitude of a vector, so I want to find the magnitude of 1 plus sine t I plus cos t j. If I want to find the magnitude of a vector, then the way that I do that is I square the x component, and we put it all under a square root, or in class we often talking about just Pythagoras. I don't like saying Pythagoras, but it makes perfect sense to you guys and girls, so let's work with that. Cos t squared, and then in order to do this I need to expand that bracket, and don't forget, when I expand a binomial expression, I have the first one squared plus 2 times the first one times the second one, which will be 2 sine t, plus the second term squared, so it will be sine squared t, and then square cos squared t. And you might initially think that this is a pretty horrible expression, So if we remember our trig identities, sine squared t plus cos squared t just equals 1. So if that equals 1, I end up with 2 plus 2 sine t as my expression for the magnitude of velocity. So this is my speed. And we want to find out when is it a minimum. Alright, so when is this value a minimum? So I can do this two ways. The first way is I can differentiate and then substitute and find out when the derivative equals 0. So I can differentiate and find out when the derivative is 0. Or I can actually be a little bit more clever about this. I know that this is going to be a minimum when the sine value is the smallest it can possibly be. So the smallest sine value I can get is minus 1. Times that by 2 and you get minus 2. So the smallest value that this expression can take is actually equal to 0. Okay, so the smallest value will actually be equal to 0. The smallest speed I can have is 0. So what I can do now is I can find out, well, when does this expression equal 0? Okay, now hopefully we're not leaving out any key terms here, but we'll see how we go. So I want to find out when is that expression equal to 0. So I can square both sides. And then rearrange the expression, and I find out when is sine of t equal to negative 1. And we find out that sine of t is equal to negative 1 at t equals 3 pi on 2. So I get a minimum at 3 pi on 2. Now if you want, if I was going to differentiate this expression, I can do that. Now if it was in an exam situation, you would use your calculator to do that, and if it wasn't a calculator exam, the chances are they'd probably lead you through that a little bit more with parts A and parts B. This expression and solve equal to 0. Okay. Now when you solve equal to 0, remember that's your maximums and your minimums, so you would have to look at the graph in order to determine which solutions are minimums and which solutions are maximums. The way I did that, just to clarify, I took the sine t and I said, when is this a minimum? Sine t is a minimum. Sine t has a minimum of negative 1 at t equals 3 pi on 2. So if I do that, I don't even have to do these workings here. It just makes sense. All right. So that is when it is a minimum. And then part C asks me in the question, what is the acceleration at? So at, we've got this word at this minimum speed. So it doesn't want to know what the velocity is or anything else. It wants to know the acceleration at this point. So it wants to know what the acceleration is when t equals 3 pi on 2. So the easiest way to do that now is we just go back to my acceleration expression, and I need to substitute in 3 pi on 2 into that expression. So if we substitute 3 pi on 2 into cos ti minus sin ti, so we'll get cos 3 pi on 2I minus sine of 3 pi on 2j. Then my acceleration at this point is, the cos part is 0, so I don't end up with an I component, and sine of 3 pi on 2 is negative 1, so I get negative 1, which is positive 1, and it is the j component. Remember, we're working in vectors, so we need to have a vector solution for acceleration. Finally, when is acceleration perpendicular to the path of an object? So we've got this term perpendicular. And hopefully you remember from when we studied vectors much earlier in the year, two vectors will be perpendicular when the dot product is equal to 0. So we want to know, when does the dot product between acceleration and the path equal 0? So my path equation, I've remembered that incorrectly. Hopefully I've remembered this correctly. I'll double check it in a moment. My path equation was this, and my acceleration equation is this. Now let me just check that path equation before I go any further. The path equation was t minus cos t plus sine t. So t minus cos t plus sine t, I and j. And then when we do the dot product, remember we multiply the I components. So we need t cos t minus cos squared t. So they're my I components. And then add it to the j components multiplied together, which gives me plus negative sine squared t. And some rearranging here, we get t, and we want that to be equal to 0, because we want the dot product to be equal to 0 for them to be perpendicular. So we get t cos t minus cos squared t minus sine squared t. Now minus cos squared minus sine squared is the same as negative 1. I'll write the whole steps in here just so you can see exactly what I'm doing. Negative 1 cos squared t plus sine squared t. And I've done that because now I've got a cos squared t and a sine squared t. We can use the trigonometric identity to say that that is 1. So we get t cos t minus 1. And we want to find out when this is equal to 0. So we want to know when t cos t is equal to 0. So move the 1 to the left-hand side. And we need to solve this expression. This is a tricky one to solve without a calculator, so I'm going to type that straight into the calculator and work out what t is. And that will give me an answer of approximately 4.92 seconds. Now if I was going to do that without a calculator, the only thing I can think of is I would draw a graph. So here is my graph of t, and then I've got my cos graph. Now my cos graph is this one. When I put those two together, I'm going to get an expression that sort of goes like this, because I'm multiplying the two of them together. Actually, that's not correct at all. Not happy with that. Remember that my cos graph had to be between 0 and 2 pi. So my cos graph's between 0 and 2 pi. So it's just going to be one revolution. And if I put those two together, it's going, when I multiply it, all of those values are going, it's going to start small. And which way will it go? It's going to actually go something like this. so it's going to increase. And when is it equal to 1? There's going to be a singular point in here that I need to solve for it to be equal to 1. That's pretty confusing actually. I'm going to have a little bit more of a think about how I would do that by hand, and I can answer that in class. At this point, just answer it on the calculator.